main attacks happening at different layers of the OSI model. And we started by explaining the attacks happening at the physical layer. And we said that the main two attacks are eavesdropping and jamming. There are some other attacks, but for now, just we will focus on eavesdropping and jamming. And eavesdropping is related to intercepting your communication, the communication between the transmitter and receiver. And why it's easy to do this in wireless networks? Because in wireless, your signal is on the air, and it's being broadcasted to within the coverage area of a base station. So anybody located within the coverage area of the base station will be able with certain devices qualified like with certain equipment and communication devices, he can record this communication the way you record a lecture or you record your voice, and then take this communication to the lab and then work on it to decrypt it and hack it and know the encrypted messages that are being communicated over the network during a certain period of time. For the jamming is a very severe critical attacks, even sometimes more critical than eavesdropping, and much easier to do it. And the way it happens, like you have a base station, and this base station is broadcasting signals to all the users in a certain coverage area. And a hacker can just bring a device called a signal generator. This device is a little bit expensive, but you bring that device. I can show you in the next lecture this device, and you generate with another device, vector network analyzer, you analyze the spectrum and you see at which frequency the communication is being conducted, at which frequency. Once you detect that frequency, you go to the vector signal generator and you generate a signal with the same frequency of the base station. And you bring a power amplifier to, after you generate the signal, your signal will be not that strong, weak. You bring a power amplifier and you magnify its amplitude and you send it with high power, a power which is even larger than the power of the base station. Then what happens? You basically you will be able to cause severe interference to the base station, and the base station will not be able to serve any user in the network. So, and you will tell me now, do you mean that all the mobile operators, their base stations, and there are subject to this attack? Yes, all of them are subject to this attack. So what they can do about it? They cannot do anything about it. Currently, they cannot do. There are some advanced techniques, but they are not being implemented right now. So how are they trusting their network and people trusting? Because most of the people are not high-tech people. I don't mean by high-tech a person with his PC who's expert in programming and he use Kali operating system and all the tools there. He will not be able to do anything with this. I'm saying expert high-tech people who can even use the communication devices, not only the PC. So who can do this attack? Usually the government and big companies with specialized equipment. But you can really make a network down and really destroy a network by this attack. This is very powerful attack, and nobody can stop it except by some really advanced techniques. Now, so the way to mitigate this attack, current systems are using either spread spectrum or frequency hopping. Frequency hopping, you keep hopping from a signal to another. But the problem with the frequency hopping uses a sequence, and based on this sequence, it hops from frequency to another. And if you go to the standard of 2G or 3G, the sequence is there, publicly known. You just get the sequence and integrate it with your code, and then you will make your jamming hops from one frequency to another. So frequency hopping is a good technique for defending against jamming when the jammer doesn't know the sequence. But if he knows the sequence, you are being killed. and you will not be able to protect yourself. So the other technique is spread the spectrum, where you, before you send your signal, you multiply it with a chip sequence that has a bandwidth larger than the signal, and then by doing so, your signal will spread and become buried within the noise, even becomes lower than the noise level. Then if anybody comes to monitor you, he will not be able to see that you are making a communication. Now, where is the problem if you are doing this hack or attack? Usually government and companies are regulating the spectrum. So any companies, for example, I already told you before in many lectures that the spectrum is very scarce resource and very expensive. And companies pay usually millions of dollars, if not billion, to buy 20 megahertz to send their data over it. Or there are huge companies running on just 3 megahertz, 2 or 5. This is to tell you how much expensive the spectrum is. And to regulate the spectrum and make sure nobody interferes with anybody, suppose you are in a country where you have 3 mobile operators and the government assigns for each one certain frequencies, and the government job is to make sure that nobody interferes with anybody. You are not allowed, otherwise the service will go down and users will start complaining. So usually the government install devices in certain areas that monitor the spectrum. It's like the police that monitors the unseen, and they see on this spectrum who's transmitting on which frequency, or who's interfering with who's, and what's going on here. And at the end of each month, they report all these cases and they send a report. Like somebody crosses the traffic light while it was red, then camera captures him and report that person to the police. Then they will fine you and like put some punishment for that act. The same happens with the spectrum. You have the police regulating the spectrum and monitoring that. I don't know if you know this, but it's a good idea to know. Yes, maybe something that you can think of it of the future. So you cannot just blindly say, okay, when I become rich, I will buy these devices and I will just jam these networks, all those mobile operators that I hate, that I really don't like. Yes, many people don't like those mobile. Anyway, then it becomes like this. When you start transmitting, if there are those devices that act like a police, they will capture that transmission, and they will, if they are high-tech people, they will know from where that transmission came, and then with specific techniques they will be able to track and find the person, or they will figure out. But if they are not high-tech people, the attacker might escape and might not even appear on their spectrum. But this is severe attack, can apply anywhere, everywhere, no defend against it, unfortunately, and can can cause a network to go down, really, literally. So those are the attacks for the physical layer. The attacks for the MAC layer. We have several attacks on the MAC layer. The attacks on the MAC layer, you have MAC spoofing. Spoofing, falsification of MAC addresses. Basically, each network, everybody among you should know that each wireless device has its own unique MAC address. Okay, and this MAC address is different from the IP address in the sense that it's hard coded in the network card, and this is assigned by the manufacturer. Let's say, give me example of a manufacturer that manufactures the network cards. So most of these manufacturers are in China, and so those like Qualcomm, ZTE, Huawei, and those are the ones, let's say, that manufacture the network card, and they assign the MAC address. Now, when you install your computer or whatever in the network, the users use this MAC address to authenticate themselves. Now, I told you before that a hacker can listen to the communication and he can get the MAC address. So in this case, imagine that someone taking this MAC address and authenticating on your behalf and spoofing and like fake cheating on the base station and letting the base station believe that you are the main the authentic user, and starts communicating with you as if you are the authorized user. So you will be able to get all the data of the other user, which is really bad and really not desirable at all. Nobody wants to be in that situation. So there are methods to prevent against this attack that we will learn them in this course. The second attack is identity theft. So basically, you steal the legitimate user MAC identity by overhearing the network traffic, and you start using for attacking, not only spoofing, but for attacking. Imagine someone is attacking a network or a computer on your name. So when they look at what's happening, they see the MAC address. They, instead of going to the attacker himself, they go to the one that they go to the one whose MAC address was stolen. Imagine how bad it is, really. So we have the man in the middle attack, which is also very nasty attack. The attacker basically first sniffs the network traffic in order to intercept the MAC addresses of the transmitter and receiver, a pair of legitimate communicating nodes. Then he impersonates each one of them, impersonate the base station with the MAC address of the user, and impersonates the user with the MAC address of the base station, and finally establishes a connection with them. So this is also a very bad attack. And also we have the network injection. You inject forged network comments and packets in the network, and with some specific comments you can really shut down the network. Unbelievable. Preventing the operation of networking devices. You don't know what happens to your router. Your router is no to your switch is no longer functioning properly. What's going on? You don't know. You found when you go to the code and you check the programming of the router, you were programming it in a certain way, and you found out that those things are not anymore the same way we programmed them. What happened? Something happened like network injection and those things. So here there is a note. Although the MAC address is unique and hard-coded in the network card, it's still possible for a network node to spoof a MAC address, and thus MAC spoofing enables the malicious node to hide its true identity, which is very bad for the owner of the MAC address, or to impersonate another network node for the sake of carrying out illegitimate activities. So that's also, as you can see here, the attacks are more and more. To defend against these, we'll teach you how to defend against these, but now we'll just go over the attacks in all the networks. So we have the network layer. Again, in network layer, we have many attacks as well, and those are similar to the ones happening at the MAC layer: spoofing, injecting, hijacking, and denial of service. Yeah, here on MAC address we have denial of service, but like it's not here, it's not being listed. But in all the layers, this point is important. You can launch denial of service attack on all the OSI layers, whether application, transport, network, MAC, or physical. So denial of service at the physical layer is basically jamming, interference. Denial of service at the network layer is launching smart attack. You basically shut down the network by launching a huge number of ICMP requests. Those internet control message protocol requests, those are just like broadcast requests. they make your network busy, and it consumes the resources, and your network will go down because there are no enough resources to serve the users. And for IP hijacking, you disconnect the legitimate user and create a new connection to the network by impersonating the legitimate user, just like similar to the Mac spoofing, and we have the same here. We have IP spoofing. There we have Mac spoofing. IP hijacking. The difference between hijacking and spoofing is the fact that you are always attacking with with somebody's else MAC address or somebody's else IP. So as if you are committing sins and just putting them on other people. Okay, the IP spoofing, you spoof and you get the data of the other user, or you try to replace him. But in IP hijacking, you are not only taking, but also using and utilizing that, exploiting that IP address to launch attacks that can be associated with the victim later on. So other forms of IP hijacking includes prefix hijacking, root hijacking, border gateway protocol hijacking. Each one of those, you can learn it, and you can even learn how to do it using. If you are interested in implementing these attacks, I recommend you to install Kali operating system. It's a Linux operating system. Some of you know it. And you can experiment with those things, but make sure you are in a network. You cannot do this on university network or public network or this. You can use these on your own network. So don't mess up with the public networks or Wi-Fi networks or the other people's network with you. Otherwise, it will be considered illegal activity. And this can be found, can be monitored, and can be, of course, not all the countries the same, but like, you need to be careful while you are testing these things. There are simulation environments, which I recommend them better than going live into practice, because the other networks are not, they are not your own networks, and you cannot disturb the other people or this. But you can build your own network and test all these things, or go to a simulation environment and experiment with those. Now, moving on to the transport layer, we have the TCP flooding. We have UDP flooding and we have TCP flooding. Both of these attacks are denial of service attacks. Think of them. So denial of service, the goal of this is to consume the resources of whatever the user or resources, and make sure that the network, when somebody requests certain thing from the network will not be able to satisfy that user, because there are no resources. So how do you do TCP flooding? So we said at the physical layer, you send jamming signal, basically signals that can interfere with the sinusoidal signal of the base station. At the network layer, you send ICMP comments, which is kind of because you are at the packet level. Here at the TCP, you send ping request. For those who took CCNA, they know what ping is and what's used for. Basically, ping, when you open the command window, so when you open the command window, you need to check your connection with a website. Yes. So you write here ping 192.68.1.1, and you just send a request to that, if there is a device in the network with this IP, it will send back. It will tell me that yes, I went back and returned with this data. If there is no IP, it will just say request timeout, request timeout. There is not. I sent 4 packets, received 0, lost 4, 100% lost. There is nothing. Imagine this IP address is in your network. Yes, here. Imagine this IP address in your network, and you are with 1,000 computer with 1,000 computers in the network. You are all of you sending all of you wrote a software program that can keeps running Bing to that PC, to that computer, to that base server. Imagine what will happen. You will consume all the resources of the server, all the resources. No user will be able to access the network anymore. So this is TCP flooding, UDP. Of course, you can do the same thing for ICMP, and UDP is for voice and video. TCP sequence prediction attack. So this is like fabrication of a legitimate user data packet using the predicted TCP sequence index. So where do you classify this? This is like hijacking, falsification of a legitimate user. And which security requirement, I can ask you the following question. Which security requirement does this attack exploit? TCP sequence prediction attack. So this is against integrity. UDP flooding, which security requirement? Availability. And so on and so forth. Questions like these you might ask, but really I recommend you to learn more about these. This is just brief, like just somebody opening the doors for you, letting you know what's going on those layers. And finally, let's go to the attacks at the application layer, which is the most of the attacks usually happen at the application layer. There are millions of attacks at the application layer. Unbelievable the amount of attacks. Why? Because it's easy to do it. You just need to know how to code and write some malicious codes and send them. Unbelievable, really unbelievable. And why? The other reason, because everybody sees the Mac layer, the application layer. Everybody interacts with the internet on the application. So with good programming skills and good networking knowledge, with good security knowledge and the operating system and resources, a hacker or attacker can launch the following attacks. You have the malware attack, the SQL injection attack, the cross-site scripting, the FTP bounce, SMTP attack, and this is just a few of the so many attacks that exist on the internet. For example, let's say you have a website on the internet, and when you launch your website or this, if you are not aware that security is important for the application, for your web, you will see how many attacks you will receive within just few months from launching your website. If your website is not secure, your website will be down within just a very short period of time. And why I'm saying this, because it's really, there are scrappers like codes scrapping the internet and going and checking the websites on the internet. So once that scrapper written by a hacker finds that this website is not secure, they have some codes that can run on multiple computers and just launch denial of service attack on your website or server. And no user will be able to use anything on your server. So this is really, really serious things. And here, malware attack, starting from what malware attack? What's malware? It's malicious software in the form of code, script, and active content programmed by attackers. You program it, and your goal is to make sure that this can reach to the destination. And once it reaches to the destination, it gets activated. So you may carry it with you. It might be in your PC, but there is a trigger for this malware. Once it gets activated, starts messing up with the things in your PC or in your mobile phone. So example of those, you have Trojan horse, you have viruses, you have worms, you have backdoors, keyloggers. You know, keyloggers, they can record each and every keyword you write on your PC anytime, anywhere, and it just writes it on the server or the website of the attacker, writes it for him, tells him what he's writing. Imagine someone just Just he's not watching you. He's not. He just records what you write on your keyboard. Very, very, very serious, I mean. And the problem, where is the problem? That you don't see these applications. Usually they are running in the background and hidden, and nobody knows what the hell this software or this is doing. And this is scary because you don't see it. Scary because you don't see it, unfortunately. And the way you do this, for example, if you want to discover some of these things, you go to Task Manager if you are interested in knowing what's going on in your PC. You click in more details and you come here to the performance. So basically you have those processes running. Yes, if I am opening Microsoft Edge, I can understand that Microsoft Edge takes this amount of memory, this amount of this amount of network. Now focus on the network. Disk and memory and CPU, they are happening at your side, okay? But the network, this is your connection with the Wi-Fi access point. Those are the apps that you can see. Only those apps that I am really opening, but see what's happening in the background. See how many softwares are running, and I don't see them as a user. You have Adobe is doing something in the background. You have many applications doing something. Now, where you need to look at the network. See if there is something being sent. And you can, when there is something being communicated and sent, then know that there is something being transmitted. You are not doing anything, yes, but there is something being communicated to some X website, some X server, I don't know, tracking me, what I'm doing here. Although I'm not touching anything, I'm not doing anything right now. Let's say, maybe you don't know, you need to be suspicious about these things. When there is when you are not browsing the internet, when you are not downloading anything or watching anything or doing anything, and there is consumption in your network, then there is something hidden going on in your PC. Now, not every hidden thing going on in your PC is, let's say, is evil. I don't know, maybe there are certain things that are critical to be happening on your PC so that it can make sure that everything runs smoothly. To prove this to you, try, for example, TeamViewer is running here and taking some part, but I don't see it. Yes, I have it installed, but I'm not opening it right now, but it's running. Skype is running, although I'm not opening it. This can really put some question marks. What's happening here? Now, if you try to close these backgrounds, to close them, you will find out that you cause some problems to your system. You will have really severe problems sometimes, especially those microservices by Windows. Go to the performance here again and check the network. This is the CPU, this is the Wi-Fi, this is your Wi-Fi connection and the throughput and how many kilobit per second have been transformed within a certain period of time. Send, receive. Those CPU, memory, disk, GPU, those are local. But if you want to see what's being transmitted from your computer to the outside, check here. Now, can you tell me what's this? You need to go to the processes. But you can see when there is something that's continuously going on. I mean, you need to think, what this is that exactly? So, and you have, this is the IP version 4, the IP of your, this is the IP of your computer. So if you take this IP and ping on yourself, you will find out that you are connected, and it will reply back with successfully sent, successfully received. This is the connection type. This is your SSID. The adapter name Wi-Fi. The SSID is the name of the Wi-Fi access point. Sent, received. How much you send, how much you receive. So this data now currently being sent and received without me doing anything. I'm not uploading anything. I'm not sending any message. I'm not, which means that there are many trackers happening in the background. Normal users, I mean, they cannot understand what this is all about, but like there is something happening. Now, I'm not saying that everything happening is bad or it's a hack or attack or this, but at least if you can figure out what that is, you can have peace of mind that you are not being hacked, but this data is being consumed because of that X application. And you better know why this X application is sending that data. So you go to the app history. So those are some of the functionalities that are important to know while you are, and you can go to the processes as well. Okay, guys. So this is the same thing happening on your mobile phone, but in your mobile phone you have much lesser control than here. Okay, in your mobile phone you don't have control over anything, little, so little, and everything is hidden from you. There is a huge business, a huge industry built on top of making things hidden. The user doesn't see them, and they are happening. But no matter what they do, if you can, and even I don't trust this application that allows me to see the Wi-Fi network, I don't trust it. I don't know if it does really show me what exactly going on in my network. The only way to trust is to bring a Wireshark on another computer or a spectrum analyzer and see what's going on, what's being transmitted and communicated. Nobody can play with the spectrum. Nobody can hide, except if you are a wireless expert and you can use this CDMA and let your communication go with the level of the noise. So those are worrying attacks. So you have SQL coming back to the attacks. You have also SQL injection. You insert like false SQL statements attempting to gain unauthorized access. These are usually happening at the website. So basically, the attacker send like try to access or to talk to the website with wrong comments. And sometimes, if there is no database security at your website, it can break your website. Really, you have a cross-site scripting, which is very common, which is about injecting client-side script. You inject codes at the client-side browser for bypassing some of the access control measures. FTP bounce, impersonating a legitimate user to gain unauthorized access as well. SMTP attack, also malicious attacks and email transferring between the SMTP server and the clients, something in between, and directs the messages to go to the junk or this and that. This is a complete course issue if you want to get into these things. So, but there are thousands. Each one of those has thousands of attacks examples. Anyway, those are the main attacks that I wanted you to know about. And in next lecture, we'll start talking about how to defend against these attacks using. I will before we exactly explain to you the main things that we will be talking about. I will just briefly explain to you how do we defend against these attacks at each layer, as according to the current existing security approaches being deployed in current wireless systems. So we'll talk about encryption, decryption, asymmetric, ECC, DSE, and those techniques, and how to hack, decrypt them, how to break them, and then know their lapses, their weaknesses, and then move on after that of learning the real stuff of what can we do about this. So thank you everybody for attending the lecture and being patient. And I think we can stop here and we follow up next lecture. Thank you. Take care. Stay blessed and see you very soon.
Thanks a lot, sir. Thanks a lot. Have a nice day.
Thank you.
Thank you, sir.